So you have just seen that when a system changes from a given initial state to a given final state, both the work W and the heat Q depends on the nature of the process. It depends on the path. It just does not only depend on the initial state and the final state, right? Experimentally, however, we find surprising result. The quantity Q minus W is the same for all processes. It does not depend on, it only depends on the initial and final states and does not depend at all on how the system gets from one to the other. So Q minus W only, only Q minus W only depends on the initial and final states, right? It does not depend on at all on how the system gets from one state to the other. Here is worth noting is that Q, we have already seen that other combinations like Q only, W only, or even Q plus W, or Q minus 2W. All these different combination of Q and W, they're just some example, are path dependent. Right, so they don't only depend on the initial and final state there. So this is surprising experimental result. These are all surprising experimental results. So there's a big difference between Q minus W or Q minus 2W or all these different combinations, right? So the quantity Q minus W must be some unique thing, something unique thing is happening there, right? So Q minus W must represent a change in some intrinsic property of the system, and that intrinsic property we call internal energy, right? So we can write that change in internal energy, so internal energy changes, so let's say change in internal energy, delta E internal, is equal to Q minus W. And this relationship, so whenever you supply Q and work is done by the system, the internal energy of the system changes, and this is given by this relationship, and this is called first law of thermodynamics. Right? And in this first law, one thing we need to remember that the W is always going to be work done by the system, right? So remember the first slide of first law of thermodynamics, that is by is important. So we can either you can write like this, or you can put this suffix by here, right? So just to clarify, so work done by the system and work done on the system. This is work done by the system. That means W by is positive, if you remember the earlier slide. Great. And also briefly we can mention what is internal energy. So internal energy is sum of kinetic energy of all of its constituent particles plus the sum of all the potential energies of interaction among these particles. So if you want, I can write it down. Internal energy. So we were talking about the internal energy. So what is internal energy? Is the sum of kinetic energies of all of its constituent particles plus the sum of all the potential energies of interaction among these particles, right? One more thing from this equation we can see that we have learned that W and Q can be positive, negative, or zero So delta internal, delta E internal, the change in internal energy can be positive, negative, or zero for different processes. Great. Thank you.